Imagine waking up one morning to find that Earth's magnetic shield, our invisible guardian, was gone. At first, nothing would seem different. The sky would still be blue. The air would still feel the same. But above your head, an invisible war would be raging. Without warning, the sun would unleash a storm of radiation, slamming into our planet with the force of 10 billion atomic bombs. GPS systems would fail. Satellites would fry. The skies would light up with auroras more violent than any seen before, not just at the poles, but across the entire planet. And this would only be the beginning. Most people don't think about the magnetic field because it's invisible. But this unseen force is what allows life to exist as we know it. Without it, Earth would be bombarded by deadly cosmic radiation. It protects our atmosphere, keeping the air breathable and the climate stable. The magnetic field is generated by the movement of molten iron deep inside Earth's outer core. This process, called the geodynamo effect, has been running for billions of years, creating an invisible shield that deflects harmful solar wind. But here's the problem. It's weakening, and it has been for the last 200 years. Scientists are concerned that we may be headed for a catastrophic change. The moment the magnetic field disappears, our planet will be exposed to the full power of the sun's radiation. Power grids will fail. Global communications will collapse. Astronauts and airline passengers will be the first to suffer from lethal radiation exposure. And over time, Earth could become another Mars, a barren, lifeless wasteland. In this documentary, we'll explore what is happening to Earth's magnetic field right now. Could a pole reversal trigger global disasters? What happens to life on Earth if the field collapses? Can we survive without it? Strap in, because the truth is more terrifying than fiction. Deep beneath our feet, something incredible is happening, something that has protected Earth for billions of years. It is the source of our magnetic shield, the invisible force that safeguards us from cosmic chaos. But how does it work? And why is it weakening? At the heart of our planet lies a seething ocean of molten iron and nickel. As these metals churn within Earth's outer core, they generate powerful electric currents. These currents create a planet-wide magnetic field, extending tens of thousands of miles into space. Scientists call this process the geodynamo effect. Without this shield, solar winds, streams of charged particles from the sun, would strip away our atmosphere, exposing the surface to deadly radiation. This is what happened to Mars billions of years ago. Unlike Earth, Mars lost its geodynamo, and as a result, its atmosphere was slowly eroded by the sun's relentless energy. Satellites like ESA's Swarm mission are constantly measuring changes in Earth's magnetism. What they've found is alarming. Over the past 200 years, the magnetic field has weakened by about 10%, and some regions, like the South Atlantic anomaly, are losing strength even faster. Every few 100,000 years, Earth's magnetic poles swap places. The last full reversal occurred 780,000 years ago. Scientists believe we may be overdue for another. But what triggers these flips? And what happens to Earth in the process? Across the globe, scientists have discovered strange magnetic hotspots, regions where the field behaves erratically. Could these be the early signs of a coming shift? Or are they something even more mysterious? What happens during a magnetic reversal? Could a weakened field lead to global disasters? How would our technology and ecosystems be affected? Stay tuned for Chapter 3, Warning Signs. Earth's magnetic field is weakening. For billions of years, Earth's magnetic field has been our planet's invisible protector. But now, scientists have detected disturbing changes, signs that this shield may be weakening. Could we be on the brink of a global event that will change life as we know it? One of the most mysterious signs of a weakening magnetic field is the South Atlantic anomaly, a region over South America and the South Atlantic Ocean where the magnetic field is significantly weaker than anywhere else on Earth. Satellites passing through this region experience system failures, unexpected malfunctions, and increased radiation exposure. Some have even been permanently damaged. Why? Because with less magnetic shielding, space radiation bombards this region with full force. Astronauts aboard the International Space Station report seeing flashes of light when passing over the SAA, caused by high-energy particles penetrating their retinas. Without a strong magnetic field, even space travel would become far more dangerous. Another warning sign is the rapid drift of the magnetic North Pole. In the past, it moved just a few miles per year. Now, it's racing toward Russia at 30 miles per year. Scientists believe this could be an indication that Earth's field is destabilizing. Some researchers are investigating whether fluctuations in the magnetic field could be influencing Earth's climate patterns. While still debated, some studies suggest that shifts in Earth's magnetic shield might be affecting atmospheric currents and extreme weather. If this trend continues, we could be heading toward a magnetic reversal, a complete flip of the poles. While Earth has survived such reversals before, the effects on modern society could be catastrophic. GPS, power grids, and global communications could be severely disrupted. Teams around the world are monitoring these warning signs, using satellites and ground-based observatories to track changes in Earth's magnetic field. But the biggest question remains: is this just a temporary fluctuation, or the beginning of something much bigger? Stay tuned for Chapter 4, Immediate Consequences, a Planet Under Attack. The day Earth's magnetic field collapses will be the day everything changes. Without warning, we will be exposed to the full force of the sun's deadly radiation. Power grids will fail. Satellites will stop working. Astronauts will be in danger. And that's just the beginning. Earth's magnetic field protects us from solar flares and coronal mass ejections, massive eruptions of plasma from the sun. Without it, these storms will slam directly into our atmosphere, unleashing radiation levels that could cripple modern civilization. Our power grids are extremely vulnerable to geomagnetic storms. In 1989, a moderate solar storm knocked out power to 6 million people in Canada, and that was with a functioning magnetic field. Without one, the entire planet could plunge into darkness. Without magnetic shielding, satellites will be fried by high-energy particles. That means no GPS, no internet, no television broadcasts, no global communication. Passengers on high-altitude flights will be exposed to dangerous radiation levels, increasing cancer risks. Space missions may become impossible, as astronauts will no longer have protection from cosmic rays. Some scientists believe the magnetic field plays a role in regulating climate patterns. A sudden collapse could trigger shifts in atmospheric currents, leading to extreme weather events, megastorms, heat waves, and prolonged droughts. With no magnetic shield, radiation will seep into Earth's surface, causing mutations in living organisms. The increase in UV exposure and cosmic rays could lead to skyrocketing cancer rates. Governments and scientists are already considering solutions, developing underground cities for protection, creating artificial magnetic shields in space, hardening power grids against geomagnetic storms. But will it be enough? And what happens if Earth's atmosphere starts to erode? Can we build a defense system against radiation? How would Earth change over time without a magnetic shield? What are the long-term consequences for human civilization? Stay tuned for Chapter 5, Long-Term Effects, a Dying Planet. Earth's magnetic field has collapsed. The immediate chaos is over, but the long-term effects are just beginning. Without our planet's protective shield, Earth is now vulnerable, facing an uncertain and dangerous future. What happens next? Over time, solar winds will begin stripping away our atmosphere, just like what happened to Mars. Slowly but surely, oxygen levels will drop, temperatures will fluctuate wildly, and entire ecosystems will struggle to survive. The magnetic field plays a role in regulating Earth's climate. Without it, weather patterns could spiral out of control. Expect superstorms, prolonged droughts, and deadly heat waves unlike anything in recorded history. With no protection from cosmic radiation, astronauts will no longer be able to survive extended space missions. Colonizing Mars? Forget it. Even low-orbit space stations could become too dangerous to maintain. Many species, especially those that rely on the magnetic field for migration, will be thrown into chaos. Birds, sea turtles, whales, all will struggle to navigate, leading to mass die-offs. The food chain will collapse. There may still be hope, Scientists are exploring radical solutions, including artificial magnetic shields in space, underground cities to escape radiation, and terraforming technology to protect Earth's atmosphere. With Earth in turmoil, will humans find a way to adapt, or will we be forced to search for a new home beyond the stars? Stay tuned for Chapter 6. Can we survive without a magnetic field? The magnetic field is gone. Earth is vulnerable, but humanity has always adapted to challenges. Can we survive this one? Or will we be forced to leave our home planet behind? Without a magnetic shield, radiation levels will increase. The only way to survive will be to develop radiation-proof cities. Scientists are already exploring underground habitats and thick shielding materials to protect against cosmic rays. NASA and other space agencies have proposed placing giant electromagnetic shields at key points in space to protect Earth. Could we build an artificial magnetic field? Some researchers believe advanced superconductors and plasma fields could help restore our protection. If Earth becomes uninhabitable, our only option may be to look beyond. Mars, Europa, even deep space habitats. Will humanity be forced to become an interplanetary species? Could humans evolve to survive increased radiation? Some experts suggest that genetic modifications might help us adapt to higher radiation exposure, just as bacteria have developed resistance to extreme environments. New technology is emerging. Advanced radiation shields for homes and vehicles, self-sustaining underground ecosystems, artificially generated magnetic fields for small communities. Are we looking at a world where only those who adapt will survive? Or can science prevent this disaster from happening? One thing is certain, humanity's greatest test is still ahead.